Okay, hi.
Hi.
Are you ready to talk about possums?
Always. Possums are the best.
Good. They're the actual best.
Such a
So
misunderstood animal. Agreed?
I know.
Huh?
Anyway, I love them. So here's a nice visual aid of a baby from the Wildlife Center.
Yeah.
So okay, back to business. We're
Yes.
working on our confidence interval.
Mm-hmm.
And suppose, let's just do an example. Suppose that in a random sample of 850 US citizens, 401 of them say that they like possums. We want to get a 92% confidence interval for the proportion of all US citizens who like possum.
Mm-hmm. So this is
So just like
important.
a little, oh, go ahead.
I was going to say this is important because we definitely can't go and sample every US citizen. That would take us years and years, right?
Yeah, so we cannot get to the entire population of everyone in the US, find out everyone who loves possums,
Mm-hmm.
but what can't we get to some of them?
We can get to some of them. 850 seems reasonable.
Yeah, I think we could get to a sample of n equals 850 of them.
Mm-hmm.
And then in our sample, we could figure out, remember, we don't use P again because it's already the population proportion.
Mm-hmm.
So P hat is our little sample proportion.
Yes.
So we can get that value. And then whatever value we get for that, probably it's pretty close to the population value.
Totally.
All right, well then let's look at the sample of interest here. So going back to the problem, we have 850 citizens. So what is that?
That's the N value.
That's the n value. So n equals 850.
Mm-hmm.
And we're asked to find a confidence interval. So I'm just like to right away remind myself these kind of are just little formula problems. And this is
Mm-hmm.
proportion. So can you remind me what is the formula for the confidence interval for a proportion?
Okay, so our confidence interval is equal to p hat plus or minus our margin of error.
Okay, great. And our margin of error is built out of the critical value, and then we have our standard error. So this isn't something we need to memorize. We can go ahead and look this up. And the nice thing is we just need to fill in all the pieces.
Totally.
The hardest part is a lot of the time people don't know which formula to use because
Mm-hmm.
this is one of three that we have. The fact that it says proportion tells us that we want to be creating a confidence interval around a proportion, right? So this is the one we want. Okay, do we have any of the pieces for inside this formula right off the bat?
Yes, so right off the bat, we have that n is equal to 850.
Okay, cool. So we're going to go ahead and just start subbing in pieces.
Mm-hmm.
May as well just put in what we for sure have.
Mm-hmm.
What's the next thing we might want to try to get?
Maybe let's try and get p hat.
Yeah, let's just see what our sample proportion even is, right? What are our samples saying? So how do we get that sample proportion p hat?
So p hat is going to be like the x, which is 401, out of n, which is 850.
Yeah, so it's the number of yeses out of the total number in your sample, which you're going to be pretty much given.
Right.
So pretty easy to find that as well. Do you know about what that comes out to?
That's going to be about 0.47.
Cool. Okay, so then that's our sample proportion. In our sample, 47% of people like possums.
Mm-hmm.
Basically, 47% of people have their lives together.
Exactly.
But that doesn't mean the population proportion is exactly that. Like we want to give ourselves that wiggle room of maybe a little above or a little below that is the truth.
Right.
So we'll use our formula. 0.47 goes in for our sample proportion, our point estimate. And then can you remind me how we find that Q? What am I calling Q?
Q is like 1 minus p hat, right?
Yeah, so Q hat, yeah, is indeed 1 minus P hat. So it's the probability of the complement.
Mm-hmm.
So 1 minus 0.47. So what do we get there?
0.53.
Nice. So we can sub that piece in as well. So like we got a lot done already and all we've really done is kind of read the problem.
Totally.
The place where we have to do the heavy lifting on confidence intervals by hand is always on the critical value.
Yes.
Yeah, and the critical value always connects back to that confidence level.
Mm-hmm.
So I'm going to go over here under this little possum for our side work, because I know we both kind of always like to go do it on the side, is discuss what's going on with our confidence level. Mm-hmm. What is our confidence level?
So our confidence level is 0.92, and let's remember that that's equal to 1 minus alpha.
Great. Okay. I like to kind of picture it. Like, remember back when we first started learning these, we would draw our bell-shaped curve and you could picture your confidence level as that middle area.
Yep. So that middle area is like that 1 minus alpha.
Yeah, that's your 92%.
Mm-hmm.
And that means if 92% is in the middle, what percent do we have to share between each tail?
Okay, so that means that alpha is equal to 0.08. And if we share that with each tail, right, each tail is then 0.04.
Right. So each tail gets about 4% of the area.
Yes.
And why do we care about this? Well, that alpha over 2, remember, plays a role in our critical value.
That's right.
That notation, we have to remind folks, is always that's the z-score under the standard normal curve, which we're drawing here, such that the area to its right is the alpha over 2. So to get like a little visual, that alpha over 2, that little subscript is just that area.
Yes.
It's not like we have to draw this every time. It's just kind of nice to visualize it when you're still learning it.
Mm-hmm.
Okay, so z sub alpha over 2 is the z-score, such that the area to the right is 4%. And you can totally use that z-table backwards to do these. I don't think that's either of our favorite ways to go.
No, let's go ahead and do it on the calculator. Can you pull that up for us?
Yeah, so I'll pull up a calculator. And by the way, before we even get there, let's note our syntax. So when you're given an area and you want to find the value along the horizontal, so given an area, want a boundary, you want to use the function called inverse norm. And we'll just remind everyone that inverse norm requires 3 inputs.
Mm-hmm.
Do you remember what they are?
Yeah, so the first one's like A sub L, area to the left.
Yeah, the left area, which is counterintuitive because that subscript is the area to the right.
Yeah, that is counterintuitive.
Yeah, the area to the left would be everything this way, but the nice thing is like the little subscript on Z and what you put into inverse norm have to add up to 100%.
Right.
So for us, what are we putting in for our left area?
0.96, right?
Yeah, you got your 92% plus that other little 4%, so 96%.
Mm-hmm.
And then you're putting in your mean and your standard deviation. But since we're talking about Z on a standard normal curve, what are those?
Always 0 and 1.
Yeah.
Yeah.
Okay, so let me get the calculator so we can demo this real quick.
Cool.
We're going to go to second vars for all of our distributions. And then we go to inverse norm. The area, it doesn't tell you, but remember, it has to be your left area, so 0.96 in decimal form. 0 and 1 for your mean and standard deviation. And enter. And I'm getting about 1.75.
Mm-hmm.
Cool. Okay, so what we got for this was about 1.75. That's our critical value. That's the z-score such that the area to the right is 4%. So by default, area to the left is 96%. And that's the missing piece to our puzzle for margin of error to get our confidence interval. So I'm going to put in 1.75. And the further you go out on that, like the more accuracy you have on that, the better. But I'm just kind of being loose right now. We're talking about possums and how much we like them. It's not life or death.
It's like a wild
Maybe
thing.
if, yeah. Okay, so what we'll do is we will now say this is 0.47. Let's get about what that margin of error all comes out to be. So let's put that whole thing into our calculator.
Okay, I think that comes out to about 0.02996.
Okay, do you want to call it 3%?
Yep, let's call it.
And again, like more accuracy, better. We're being kind of loose. It's not a high stakes problem.
Yeah.
Okay. Okay, so I like to draw the confidence interval before I get my bounds, especially when the numbers aren't as pretty as this. Like this is nice, easy to visualize. But I like to see that margin of error kind of swing around both sides. And then it's really easy to see like what's our lower bound.
So our lower bound would be 0.44, and then the upper bound would be 0.5.
Cool. So our confidence interval is 0.44 to 0.5 in interval notation. What does that mean?
So what that means is that we are 92% confident that between 44% and 50% of US citizens like possums, i.e. have a heart and soul.
Yes. Basically, that's how many people get it.
Yes.
Cool. Now, this is doing it all by hand, but we both know there's a faster way to get that interval, don't we?
Yes.
All right. So let's look at obtaining this confidence interval on the calculator. So for now, we want to make sure we can do these by hand. Like understanding the breakdown, doing these by hand does bring a lot to the table. I think we both feel that way.
Yes, absolutely.
But once you get the hang of them, and when we go on to like higher level confidence intervals, it's really handy to be able to whip through them on the calculator and just focus on that interpretation. So we can start playing with the calculator now where they're kind of basic. Okay, so we go to stat tests. I know we're not conducting any tests yet, but confidence intervals are a method of hypothesis testing later. So that's why they're under this menu. And so what we want to find is the intervals. These all say test. We want to scroll down to all the ones that say intervals int. So these are all confidence intervals. And we just found a 1 proportion Z interval. Remember, we're talking about proportion, so that part's obvious. Z, because these are critical value, which is always true when it's a proportion. So I think just remembering which test, or excuse me, which function we're using is sometimes kind of hard.
Yeah.
Once you know, it's just describe the scenario you're in.
Right.
And then tell me, what do we put in for these pieces?
Okay, so the X was 401, right?
Yes.
And the N was 850.
Cool.
Okay, our sea level was 0.92.
Yeah. Awesome. And then when we do it on the calculator, we're getting about 44% to 50%. See up at the very top where it's giving you your confidence interval?
Yeah.
It has more accuracy. We rounded loosely. Notice they took p hat, they being whoever wrote the algorithm, and the little like elves inside your calculator took p hat out several more decimals than we did. That's fine. We were a little bit looser about it, but it's just nice to see you can get that answer so quickly.
Totally. And you know, our students should always check our work if they're asked to do it by hand, you know, always check it with the calculator.
Yeah. So we could go back and like start kind of creating a collection of sort of a summary of what all the different confidence intervals look like. I feel like having that handy is what gets me through like chapter 8, basically, which is our chapter on confidence intervals.
Totally.
Okay. So a confidence interval for, that's a creepy 4. For P using the sample proportion p hat. By hand, what does that look like?
So that looks like p hat.
Yes.
Plus or minus that critical value, so z sub alpha over 2. And then times the square root of p hat q hat, all divided by n.
And again, I call 1 minus p hat, I call it q hat because it's faster to write. Some people leave it 1 minus p hat.
Yep, either one.
That's by hand. And then on the calculator, the place that we went was 1 proportion z interval.
Mm-hmm.
So I love having a summary here, and then I just have to look at the problem and ask myself, like, which case am I in? This was case, we'll call it case 1. Where we want a confidence interval for a proportion, a population proportion, using a sample proportion.
Mm-hmm.
Next, we might want to look at a confidence interval for a population mean using a sample mean. So how would that be different?
All right, ready to try another one?
Yep.
Okay, so in this problem, we're looking at a sample, a random sample of 9 calculators being sold over the internet, and we're looking at the prices of those. And so they're listed right here, $135, $163, and so on. And it says, assume the population standard deviation is $28, and that, whoops, I'm covering this, and that the population is approximately normal. By hand, construct a 95% confidence interval for the mean price for all the TI-84s being sold over the internet. Okay, so first, let's just go ahead and remind ourselves of the confidence interval formula for the population mean. Do you want to help me with that?
Yes. So in this case, because it tells us that sigma is known to be $28, we're going to use the formula when we know sigma. So it's going to be our sample mean, which is x bar, plus or minus, and our margin of error comes out to be that critical value, which is still a z-score. Yeah.
That's right.
Times the standard deviation of the population that we know, so times sigma over root n.
Perfect. Okay, so now, like we did last time, let's just go ahead and figure out what we know already. So like there's something screaming out at me right away. What do you see?
We can definitely sub in 28 for sigma.
That's right. So this can go here. Okay, so equals 28. Okay, what else?
The n, the sample size is 9.
Okay, so that is going to be 9. This.
Nice.
This. Okay.
Okay, so the critical value I know we always have to like work a little bit for. So the x bar I think we could find first.
Yeah, let's go ahead and find x bar. So let's do it on the calculator. Can you help me out with that? So, you know, x bar means the mean of all of these right here.
Right. So I'm going to go ahead and go to the calculator. So I went ahead and, because we're going to need to later anyway, I went ahead and put stat edit all of this data into a list, into L1.
Perfect.
And then instead of just adding them all up and dividing by 9, I'm going to let the calculator do that for us. Okay. So we're going to go stat calc, 1 variable statistics on this one. And I'm getting like 152.3 repeating dollars.
Okay, perfect. So I'm just going to go ahead and since we're talking about like dollars and whole numbers right now, I'm just going to go ahead and call it 152.
So in our sample, we have an average of $152. That's probably about what the average is for like all of these babies out on the streets. But like we know plus or minus, we want to give ourselves that wiggle room of like $152, maybe a little more, maybe a little below, right?
Yep. Okay, so I'm just going to go ahead and plug in that 152 into the formula. Okay, so that's here. I have, you know, I know how you feel about color coding, so. Okay, and we still have to find our critical value.
Right.
Okay, so let's go ahead and do that to the side. Confidence level is what?
95%, so 0.95.
So 0.95, which means that our alpha is equal to what?
0.05, 5%.
This was equal to 1 minus alpha, right? So this means that alpha is equal to 0.05, which means that alpha over 2 is equal to what?
0.025.
0.025. And remember, if we look at this visually, okay, what is this shaded region? Hold on. Right here again?
Okay, that's the confidence level, which is 0.95.
Good?
Yes.
Okay, so then what we're looking for is z sub alpha over 2, so 0.025. And we're going to go ahead and do that on the calculator again. Okay, so remember that it's inverse norm, right? And then we're going to input those three things. Remember that first thing is that A sub L. So Lindsay,
Yeah.
how are we going to find that?
Well, the z-score is the one such that the area to the right is the 2.5%. So that means the area to the left is everything else. So it would be, yeah, 95% plus 2.5%. So 97.5. So 0.975.
Good. Okay, so that's what goes there. And then again, we have the mean and standard deviation, which is always what?
0 and 1.
0 and 1. And can you go ahead and calculate that for me?
Yes, that comes out to about 1.96.
Okay, cool. So that's about 1.96. So what we're going to go ahead thank you. What we're going to go ahead and do is plug that back into our formula. So this is 152 plus or minus 1.96 times 28 over square root of 9, which is 3. And we plug that puppy in, and what do we get?
1.96. What was that?
My email.
I'm getting about 18.3, so I guess we could just call it $18.
Okay, cool. So about 152 plus or minus 18. So this 18 is called like what in the context of this problem?
The margin of error.
Right, the margin of error. Okay, so I'm going to go ahead and draw this on a number line now.
Okay.
Remembering that 152 is that sample mean, and we just found that our margin of error is 18. So we can swing that 18 in both directions to find our confidence interval. So from here to here is 18, making the upper bound, making the upper bound equal to what?
$170.
170, and if we go in the other direction, 18 as well, makes the lower bound of that confidence interval equal to what?
$134.
Okay, awesome. So what I'm going to do is have you summarize exactly what this means, and I'll go ahead and write that down.
Okay, so we are 95% confident that the population mean price of one of these babies is between $134 and $170. So when I say population mean, I just mean the mean price of all of these calculators in all of the lands.
Right, and important to note that, right?
Right.
We took our smaller sample size, and our confidence interval is representing the larger population.
Yeah, and a lot of time, you may have noticed this too, a lot of the time people in their interpretations, they'll write something like, we are 95% confident that the sample mean is between 134 and 170, or that the mean of the 9 calculators. And I'm like, we're 100% confident what that mean is. That means 152. Right.
Exactly, we found it. Exactly.
Yeah, we know what that is. We are not just 95% sure. We're 100% sure about what the sample mean is. We're then extending and saying we're 95% sure that's true for the whole population.
Yeah, another thing I think people do is they don't write this at all, right? They say that we're 95% confident the price is between 134 and 170. That would also be not, not explaining in the way that we need to.
Right, and that's where the big money points are on a test, is that interpretation.
Totally.
Because to be fair, the calculator can do everything else.
Yes.
In fact, you want to do this the shortcut way on the calculator?
Mm-hmm. Yeah, let's do that right now.
All right, let's do it. Okay, so again, we're going to go into our stat tests. I know we're not conducting a test, we're constructing an interval. Later, we will learn that those intervals can be used to conduct a test. All the tests are going to be first. So we're going to scroll past those. We want an interval right now. And you want to ask yourself, which scenario are we in? We're in the scenario where we had Z as our critical value, and it's an interval. Mm-hmm. So we want Z interval. And then we press enter. And it's going to ask us, do you have data in a list? Or do you want to give me the statistics? And we have data in the list. Remember, we put it in L1?
Yep.
So we may as well just tell it we have data in the list, but it needs us to tell it what the population standard deviation is. So what was that?
28.
Cool. And then our confidence level was 95%, correct?
Yes.
And we're getting from about $134 to $170, same thing we got by hand. So far, our summary included the confidence interval for the population proportion using the sample proportion. That was all about proportions. Right. But now, what are we doing?
So now we're doing the confidence interval for the population mean. Mm-hmm. And in case one, it's when we have the standard deviation of the population.
Right. So the standard deviation is known. Let me move over just a little bit. Okay. So talk to me. By hand, what is our formula?
Okay. So it's the sample mean, X bar.
Okay.
Plus or minus the margin of error. And if we break that down, it's the Z sub alpha over 2.
Cool.
Times sigma over root n.
Nice. So that was by hand. And then when we went and did it on the calculator, we remembered that we were using Z as our critical value. Mm-hmm. So it was Z interval. And then we just put in the inputs.
Totally.
And on the one above, let me box this up because I like them to look real pretty.
Yeah.
When on the one above, we were using Z as well. And so in its command on the calculator, there's a Z in it. Mm-hmm. But it's also describing that it's a proportion on the one above.
Yes.
On Z interval, it doesn't say anything about it being a mean. So just know that when it just says interval or just says test, when we get to that, we're working with means. When we're working with a proportion, it specifies in the calculator commands.
Awesome.
Cool. So do you want to go to the case when sigma is not known?
Yeah, let's do that because I think that's actually most of the time that we're not going to know sigma.
Yeah, a lot of the time it's kind of weird. Why would we know the population standard deviation?
That's not information we walk around with in real life.
Yeah, not if we don't know the population mean. You kind of need the mean to get the standard deviation. So yeah. Anyway, more often than not, you're going to see case 2. Okay, we're going to do an important one about dogs and the moms because it's so important.
Hi, baby.
This one's featuring Dexter. I'll share it.
Hello, Derek.
Dexter/Derek. One time my mom called him Derek on accident because she was just trying to think of his name and it starts with a D. This was when I first got him. And so she was just Derek! And it was so funny that it stuck and he recognizes that as his second name.
So great.
But his name is Dexter, okay? And he's my son.
Oh.
And here's our problem. The following data represent the age in days at which puppies first bark. According to a survey of 12 doggy mamas, that's just what the info came from. But by hand, we're going to construct and interpret a 95% confidence interval for the mean age at which basically all puppies would start barking. And they never stop. Do they, Dexter/Derek? He's like, I'm being a perfect angel. Stop. Okay. So what we have here is our raw data, right?
Mm-hmm.
And so 12 dog moms were like, I noticed that at day 52, my puppy started barking. And another one was like, I noticed it at day 30, etc. So we got all of our data. So we'll want to put that into a list if we want to do things like find the mean or the standard deviation of the sample, etc., right?
Yes.
Okay. Why don't we do that, and then we'll go back and read what the problem wants for us.
Okay.
Can you hear those dogs barking?
No, I can't.
Well, they're barking.
I wonder what day they're barking on.
I don't know. I wonder how old they are. Okay, I'm going to grab the calculator.
Okay.
So I went ahead and entered in the 12 data values into L1. So in our sample, let's just kind of see what's going on with it. In our sample, the average number of days when a puppy started barking was about what?
About 38.25. So we'll say 38.
Yeah, 38-ish days.
Mm-hmm.
Great. And then we also can notice what the sample standard deviation is. And the sample standard deviation, remember, is the S, 10.00. We can call it like 10 days.
Yeah. All right.
Okay, so after running one variable statistics on our calculators, we obtained what for our sample mean?
We got 38.
38 days. And then what did we get for our sample standard deviation?
We got 10.
Cool. Okay, let's go back and recall what the problem, or reread what the problem is asking us to do.
Okay.
So by hand, we are asked to construct and, of course, interpret a 95, oh, that was creepy of me, a 95% confidence interval
Mm-hmm.
for the mean age at which a puppy first barks. So the confidence interval is just, you want to ask yourself basically which formula is applicable.
Yes.
And when you literally see the word mean,
Mm-hmm.
do not start writing P's on your paper.
Right.
Right?
It's not
People start going, oh, proportion. I'm like, it literally says the word mean. So we want a confidence interval for the population mean mu,
mm-hmm.
using, of course,
the sample mean.
Right. So we're going to take the X bar, whatever the mean is in our sample,
Mm-hmm.
and we're going to swing a little margin of error around it. We're going to say, well, whatever happened in our sample is probably true for the whole population of all puppies, right?
Mm-hmm.
But we give ourselves that wiggle room. The difference between this and the last problem, though, is if we reread the problem, was there anywhere in there where we were given sigma?
No, we don't have that.
Yeah, we're not given sigma. So just a quick little reminder, if we don't have a population value, like right now, we really want mu,
Mm-hmm.
but we don't have that. So we're trying to get the next best thing and use it to estimate mu. So we're using X bar.
Yes.
And then right now we're also in another situation where we don't have sigma.
Mm-hmm.
So unfortunately, we don't know either of these things. What would be the next best thing to using sigma?
So the next best thing is S, right?
Yeah.
Standard deviation of the sample.
Right. If we don't have a population value, we use the next best thing, which is the sample value.
Yes.
So we're going to use S. But then if you remember, when we worked through that formula where it was sigma over root n, I'm going to erase that. When we return to that formula, before it was sigma over root n, but now we're going to be using S since we don't know sigma.
Exactly.
But now that we're using S, what do we definitely have to use instead of Z?
So whenever we see the S, we know we need to use the T instead of the Z. Right? S and T always go together.
Right. Remember our little like stats and how like S and T are always together.
You're so cute.
Thanks. Okay. So the thing is, like, we still call T a critical value. Were you laughing because I was just continuing to color that?
Yeah.
I'm really invested in my.
Yes.
But it helps.
It does. It does.
Okay. We still call T the critical value, and it is still where most of the heavy lifting is in a confidence interval problem by hand. Because don't we basically have all the other pieces to this? Yeah. Okay. So talk me through. Let's go ahead and create our confidence interval. What is our X bar sample mean?
So X bar was 38.
Cool. And we're going to swing around. I'm just going to leave some space for our T journey in a little while.
And then S was 10.
We know that S is 10. And then do we have an N?
We have an N that's 12 given in the problem.
Right. So they told us N was 12 doggy mamas. You could also look on your in your list, you put 12 data values in there. So the only thing we have to work for is that critical value, what goes there. So that always connects back to the confidence level.
Yes.
And we like to do that as side work together. So let's discuss. The confidence level is what?
95%. So let's say 0.95.
0.95 for the confidence level. Gotcha.
And let's say that that's equal to 1 minus alpha, like we always do.
Yeah, cool. Which means?
Yeah, which means that alpha is 0.05.
Cool.
Which means that alpha over 2 is 0.025, right?
Correct. So we want the T value such that the area to its right is 2.5%. And we're still on a bell-shaped curve. It's just now that we're using S instead of sigma, we know that curve's been stretched out. It's tail heavy.
Yes.
That standard deviation, the sample standard deviation is always a little bigger, so it stretches our curve out. I always think T for tail. There's more area in those tails. So people who are fancy and have the TI-84 can use that to find T with inverse T. Like we were doing inverse norm to find our Z.
Yeah, same thing.
Right. But if you're on the TI-83, you don't have inverse T on your calculator. So you'll need to use the T table that we like skipped as far as Z table went. But the T table is actually even easier to use, huh?
Totally.
Yeah, so let's get our T table and see about what our critical value is so we can wrap this thing up. Okay, so going to our T table, which if you don't have a T table saved, as like your screensaver on your phone, like a normal person, then give it a goog. All T tables are the same, right?
Totally.
Also, we of course post T tables for our students.
Of course.
But they're all the same.
Yes. Okay, so let's start with knowing that the area to the right is 0.025. So let's highlight that column. It's in the middle there.
Yeah, so the right area is 0.025. Got it. What's the other piece of info that we need?
We need the degree of freedom, which is equal to n minus 1.
And n was our sample size. What was it?
So that was 12. So we get 12 minus 1, which is 11. So let's highlight that row 11 and see where these guys overlap.
Which is, by the way, the best number ever. Just saying.
11?
Yeah, my birthday's 11/11.
Oh, yes. That's right.
Try to keep up. Okay, so I'm getting about 2.201.
Cool.
So the T table's pretty easy to use, right? So that is our last little missing piece to the puzzle, 2.201 is our critical value. So 38 days as the first day they barked, plus or minus limit of error. We put all that into our calculator. Beep, boop, bop. What do we get?
We get about 6.35.
Cool, about 6.35 days. You could call it 6 if you want to round to whole numbers like the original data set is.
Yeah, surprise us.
Yeah, surprise us with your however far you want to go out. But the online homework systems are pretty picky. So they'll say like, round to 4 decimals. So just do what you're told there. Right. Okay, so let's picture this. I'm going to write approximate. On our interval, we have 38 days as our mean of our sample as the number of days at which puppies first bark. And then we're going to swing our margin of error around both sides. And talk to me, what would be the lower bound of our interval?
So the lower bound would be 32.
Cool. The upper bound?
The upper bound would be 44.
Cool. All right. So our confidence interval is 32 to 44. And another way we can write that I don't think we've written today yet, is you can always write it in interval notation, that we are 95% confident that the population mean is between 32 days and 44 days. I kind of like that because it reminds you what we're even talking about.
Totally.
And a lot of the time in the homework, it just leaves like a box here and here. Mm-hmm. And you just have to like fill those in. Mm-hmm. So go ahead and go for it.
Yeah.
Okay, do you want to help me interpret it?
Yes. Okay, so what that means is that we are 95% confident that the population mean is between 32 and 44 days.
I'll go ahead and just put in the interpretation at which a puppy first barks.
Okay.
I just got excited because we're talking about puppies.
Yeah.
Okay, but wait, then tell me what you said at your end. That was all totally like what I should include.
Is between 32 and 44 days.
Cool. And again, this is the focus, is the interpretation.
Yes.
Because, quite frankly, the calculator could find the interval for us in like 3 pushes of the button.
Totally.
Why are we doing it by hand right now? So we can really understand that breakdown. Mm-hmm. And get that interpretation, like knowing that construction helps us interpret it better.
Yes.
But soon we're going to get to where we're working with more than one sample, aren't we?
Exactly. So yeah, it's important to understand what this stuff means.
Yeah, and when we get to more than one sample, we will let the calculator do that heavy lifting.
Yeah.
So do you want to practice this one on the calculator and then summarize?
Awesome.
Okay, so we're going to go in and we recall that we already put this data into our list. Mm-hmm. So that's done. So then we can go to our stat and tests. Remember, everything about hypothesis tests is first, and we have not even entered the hypothesis test world in our course yet. So we scroll down until we get to all the interval stuff. Yeah. So which one of these applies to this scenario?
I think that T interval there, right? Number 8?
Yep. We use T instead of Z because we had to use S instead of sigma. S and T are besties. So T interval. You can either enter in your stats. This is kind of cute though. Remember how like whenever you press enter here, if you've already run 1 bar stats, kind of cute, kind of creepy how your calculator already knows your mean and your standard deviation. Mm-hmm. Mm-hmm. And it takes it out a little further than we did, which is nice.
Yeah.
Or you can just use data and be like, it's in there, like go for it, calculator.
Yeah.
But either way, we do need to tell it our confidence level, which I think is 95, huh?
Uh-huh, it is.
Then we're ready to go for it. And at our top here, we are getting from about 32 days if we round to about 45-ish days. Yeah, to about 45-ish days, but like we got 44. We were pretty loose on the rounding by hand.
Mm-hmm.
So not only is the calculator faster, it's more accurate.
Right. And we rounded in multiple steps. So of course our answer could be a little bit different at the end.
Yeah, and when it's kind of like a low stakes problem, like we're just talking about puppies.
Yeah.
Not like how much medication to get someone.
Yes.
We can be a little like liberal with our rounding, but and I like to be that way when I'm first learning or teaching this.
Yes.
Then when we get really strong on it and we're doing more like severe problems, we're going to take those decimals out a good amount.
Yeah. Although puppy barkings is extremely important.
It's like so important.
Ready, Dexter? Speak.
Okay. Let's summarize. Okay, so back to our summary page. Okay, so back to the summary page, which arguably is the most helpful page when you're first learning confidence intervals. Because whether you're going to do the calculator method or the by hand method, you got to figure out which setting you're in.
Yes.
Right?
Kind
so
of
on what's that?
It's kind of the whole thing.
It's kind of the whole thing. So right now we know we're in the setting where sigma is not known. We still want a confidence interval for the mean. So talk me through what our formula has been adjusted to.
Okay, cool. So again, X bar, that sample mean, plus or minus the margin of error, but a little bit different this time since we don't know sigma. So now it's going to be T sub alpha over 2. And then times S over root N.
Nice. And so we're using our S, like you said, which means we're playing with T. So on the calculator, which interval did we use?
We use that T interval.
Right. Nice. So anytime you're using an S, you got to use a T in place of Z.
Yes.
We've got a more tail-heavy bell-shaped curve. So here's where you want to look. Anytime you're asked in your homework, on a quiz, test, at a party on the weekends, on the streets.
On the streets for sure. Yeah.
On the streets, like, hey, do a confidence interval.
Do we know sigma or not?
Yeah, just put this in your favorites photo album on your phone. You're welcome, America.
You're welcome.
Okay, so that was a lot of fun for confidence intervals for now. Shall we call it a day?
Call it a day. Namaste.
Namaste. Good, Dexter. Wait. Okay. Good boy. Wait. Good boy. Wait. Okay. Yes. Wait. Okay. Yes, Dexter. Very good boy. Wait. Okay. Yes, good, Dexter. You're so